Good evening. Today is Monday, February the 1st. Today in geometry, we looked at similar triangles, and I will share my screen and show you what we worked there. If you'll remember, we talked in a previous chapter about congruent triangles, and we used side, 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 angle, side, angle, and angle, angle, side techniques to prove triangles congruent. So what we're going to look at today is what does it take to prove that triangles are similar. So I'll share my screen here and show you what we're looking at. So there are two basic types of figures that you'll run into when you're talking about similar triangles. The first one is something similar to this, where you have a triangle, some size triangle, and then so let's say this is triangle ABC. This would be A. This would be B. And this would be C. Now, and then you do a line across or a segment across the triangle here that is parallel to one of the two sides. So this side here is parallel to this side, and we'll call this side DE. So this would be D, and this would be E. Now, if you remember from parallel lines, this angle here at C, this angle down here, and this angle here, which would be angle ADE, are congruent because they are corresponding angles. And then the same thing would happen over here with this angle, if we do the arc here across this. So this angle AED and angle B down here are congruent. So we have a theorem that says if two angles of one triangle are congruent to two angles of a second triangle, then the triangles are similar because their third angle, in this case it's a reflexive angle, but all three angles of one triangle are congruent to all three angles of another triangle, and that's one of the ways. So that's what's called the angle-angle theorem. We prove two triangles are similar because two angles of one are congruent to two angles of the other. So that's the first thing. Now the second thing, so I'm going to go ahead and get rid of this, but this is the first picture. So pause it and look at it. Now let me just say this, okay? Let's say we come in here and put some numbers on this. So like let's say this is 4 here, and the whole thing is 6, so that would make this 2, and let's make this 2 over here. Now and this 1. So what you see here is that you have, and then I could come down here and let's say this would be, say, 8, and now let's don't make that 8. Let's undo that 8. Okay, let's make this 6. And this would be 4, okay? Now, so the second thing that we can look at is we can have a side-side-side similarity, and if we have a side-side-side similarity, then the ratio of the sides has to be the same. So if we come across here, see, we would have one ratio equal to the second ratio equal to the third ratio. Now, when you look at this, you can say, okay, the right side of the small triangle is 4. The right side of the big triangle is 6 because that's this 4 plus 2, okay? The left side of the little triangle, the small triangle, is 2. The left side of the big triangle is 2 plus 1, which is 3. And then the bottom side of the small triangle is 4, and the bottom side of the big triangle is 6. So if you'll notice, each one of these fractions or ratios reduces to 2/3. And since they're all in the same ratio, then that is your requirement for a side-side-side similarity. Now, the third thing we're looking at, and I'll go ahead and erase this. If you have to pause to look at it, go ahead and do that. Then I'll erase this, and we'll look at the third thing, which is a side angle side. And when you're looking at a side angle side similarity, we can have one triangle over here. Let's say this triangle is here. And we can do, if I get this thing to stop moving, okay. So this would be, let's say, and then we have a second triangle over here. Let's make it a little bigger, see? So we can make this one a little bigger. And then we can come back like this. Now, so if we can say that, let's say this angle here, let's call this angle 40 degrees. And we'll call over here and we'll say that's 40 degrees. And we'll say this angle here is also 40 degrees. Now, the side angle side similarity requires the corresponding sides to be in the same ratio. So once again, let's say this is 4 and this is 8. And then down here we can have 5 and we can have 10. Okay, now, so what we have, see, we have a side angle side type situation, side angle side. The angles are congruent, and then if we look at the ratios, we have 4/8 because top of small, top of big equals 5/10, which is bottom of small, bottom of big, and both of these ratios reduce to 1/2. So since the ratios are the same, then we have similarity between these two triangles because of the side angle side requirement. Okay, now let me show you here, and once again, I'll go ahead, if you want to pause this and look at it, you can do that. I'm going to erase, and I'm going to show you one final thing that we haven't looked at, which is a type of figure that you get quite frequently in similar triangle situations. And what it is, you have two parallel segments. You have a segment up here, say, and then you have a segment down here somewhere. It doesn't have to be the same length, it just has to be parallel. And then you connect the endpoints of these two segments in an alternative manner such as this. See now, so these two the top and bottom segments are parallel. Now, so if you remember from our parallel lines, then this angle here, this angle, and this angle are alternate interior angles. And then, of course, this angle here and this angle here are also alternate interior angles. And, of course, we have vertical angles right here in the middle. So we have basically two triangles where we know that all three pairs of angles are congruent. So by the angle requirement, we can say that this top triangle and the bottom triangle are similar. Now, they don't have to be equal. They can be congruent, but they don't have to be. So those are the types of things we looked at. I'll stop sharing here at this point. If you have any questions, as you look through your textbook and look at your homework requirements, if you have any questions, be sure to send me an email. And as always, kind of keep in touch with me. Let me know how you're doing. If you're having trouble, then we can work and try to get you through it. But it's good to hear from you, and just let me know that you're still working and you're still understanding everything that we're doing. So keep me informed about how everything's going for you. Okay. So I'll go ahead and stop the recording now. I hope you're doing well, and I will be back with you tomorrow evening.